Ever wondered how the internet, this vast digital universe, works? How a simple click transports you from one side of the world to another? Imagine this. You're sitting at your desk, you type in a URL, and voila, you're transported to another realm. But how does it happen? How does this intricate web of connectivity function? Well, it's like an invisible highway, a series of pathways that your data travels. Intriguing, isn't it? Well, today, we journey through the invisible pathways of the internet. It all starts when you type a URL, but what happens next? You see, a URL or Uniform Resource Locator is a lot like the address of a house. Just as you need an address to find a house, you need a URL to find a web page. Each web page on the internet has a unique URL that points to its specific location on a server somewhere in the world. So when you type in a URL, you're essentially asking your computer to find and retrieve a web page from a specific server. But here's the catch. Your computer doesn't understand URLs. It's like a tourist in a foreign country who doesn't speak the local language. And just as a tourist might use a translator to communicate, your computer uses a system to translate the URL into a language it can understand. This is where the domain name system, or DNS, comes into play. Imagine the DNS as a massive phone book for the internet. You know how in the old days, if you wanted to find someone's phone number, you'd look up their name in the phone book? Well, the DNS works in a similar way. When you type a URL, your computer refers to the DNS to find the corresponding IP address, which is a unique string of numbers that identifies each server on the internet. The DNS translates the URL into an IP address, and voila! Your computer now knows exactly where to go to find the web page you're looking for. It's like translating "where is the library" into the local language and getting pointed in the right direction. But that's not all the DNS does. It also keeps the internet running smoothly by making sure that all IP addresses are unique and that they correspond to the correct URLs. This way, when you type a URL, you're always directed to the right web page. So the URL is our starting point, and DNS is our translator, guiding us to the right address. Now that we have the IP address, we arrive at our destination, the server. Picture a massive storage house brimming with information. This is essentially what a server is. It's a powerful computer that hosts the web pages we access. Every time you click on a link or type in a URL, you're reaching out to a server somewhere in the world, asking it to send you a web page. But how does it work? Well, let's break it down. When you enter a website's address into your browser, your computer sends a request to the server where that website is hosted. This request is like saying, "Hey, I'd like to see this web page, please." It's a polite way of asking for information. The server, receiving this request, springs into action. It finds the web page you're looking for and sends it back to your computer. The server doesn't just dump the whole web page on you at once. Instead, it breaks the web page down into tiny pieces called packets. These packets are then sent over the internet, like a swarm of bees carrying sweet honey back to the hive. Each of these packets contains a small chunk of the web page. They might have part of a picture, a sentence of text, or a sliver of a video. Once they reach your computer, they're reassembled to form the complete web page. It's like putting together a jigsaw puzzle, with each packet being a piece of the puzzle. Now, this might sound complicated, but it all happens in the blink of an eye. Servers are designed to handle thousands of requests every second, so they're incredibly efficient at fetching and sending data. And it's not just web pages. Servers also store and send emails, files, videos, and a ton of other data. So next time you're scrolling through a website or watching a video online, remember that there's a hardworking server out there, diligently sending packets of data your way. So the server is like the library, and it hands over the book you've requested. With the web page data in hand, we now embark on the journey back. And folks, this is where the real magic happens. Let's dive into this fascinating world. Imagine the data as a huge, complex piece of machinery that needs to be transported from one side of the world to the other. It's far too large to move in one piece, right? That's where the Transmission Control Protocol, or TCP, steps in. This protocol, a key part of the internet's DNA, is the great organizer of the data world. It breaks down this massive machinery, our data, into manageable, transportable packets. These packets are like little suitcases, each carrying a piece of the larger machine. They're labeled with their destination address and the order in which they should be reassembled. But how do they know where to go? That's the job of the Internet Protocol, or IP. It's the world's most efficient mailman, ensuring each packet gets to the right place. Now, these packets don't all travel by the same route. Oh no, they're adventurous little things. They each take different paths, hopping from one network to another until they eventually reach their destination. This is the beauty of the Internet's design. It's a network of networks, allowing for multiple paths to the same endpoint. Once all the packets arrive, another marvel unfolds. Remember how they were labeled with the order for reassembly? Well, now it's time for the big reveal. The TCP steps in again, taking each packet and piecing them back together to reform the original data. It's like a puzzle, each piece fitting perfectly into place to form the complete picture. If a few packets get lost along the way, no worries. The TCP has a system in place for that too. It keeps track of all sent packets, and if it notices any missing, it simply sends a request to retransmit them. It's a foolproof system, ensuring that the data arrives intact and in order. So the data takes a trip back home in neatly packed suitcases, ready to be unpacked. It's a long journey, but one that takes mere seconds to complete. That, my friends, is the marvel of the Internet. Finally, the moment of truth. The web page loads, but what's really happening behind the scenes? Let's unravel this mystery. Our journey has brought us back to the browser, the unsung hero of our digital escapades. The browser, be it Chrome, Firefox, Safari, or any other, has a vital role to play. It's not just a tool to surf the web, it's more like an interpreter. It deciphers the complex web of data that it receives and presents it to us in a format we can understand. Now, let's talk about this data. It's not just one type, but a mix of different languages, each with its own purpose. You've got HTML, the skeleton of the web page, giving it structure. You have CSS, the stylist responsible for the look and feel of the page, the colors, the fonts, the layout. And then there's JavaScript, the brains of the operation, adding interactivity and functionality to the web page. The browser reads these languages line by line. It follows the instructions laid out by HTML, CSS, and JavaScript to construct a web page. HTML tells the browser what elements to include, like headings, paragraphs, and images. CSS instructs the browser on the styling of these elements. Want a background color of midnight blue? CSS has got you covered. Need a fancy drop-down menu? JavaScript steps in. Every element you see, every color, every button you can click, it's all thanks to this trifecta of languages and the browser's ability to understand them. It's like putting together a puzzle, with each piece representing an element of the web page. And when all the pieces come together, voila, you have a loaded web page. But remember, this isn't a one-time process. Every time you visit a new page, the browser repeats this process, interpreting new data, piecing together a new puzzle. And there you have it. From URL to a loaded web page, that's your digital journey in a nutshell. So the Internet isn't as mysterious as it seems, right? Let's rewind a bit and recall the steps we've just traversed. It all starts when you enter a URL, a unique address that tells your browser where to look. This is where the domain name system, or DNS, steps in. Acting as the Internet's phone book, it translates that URL into an IP address, a set of numbers that computers understand. Then begins the journey to the server, the storage space where the website you want to visit resides. This server could be halfway around the world, but thanks to the Transmission Control Protocol and the Internet Protocol, or TCP/IP, your request zips through the vast web of connections that is the Internet. TCP/IP is the courier service of the Internet, ensuring your request gets to the right server and the server's response gets back to you. Once the server receives your request, it retrieves the web page you're looking for and sends it back to your browser. Your browser, the final piece of this intricate puzzle, then translates the raw data it receives into the web page you see on your screen. And there you have it. A whirlwind tour of how the Internet works, from typing a URL to the web page loading. We've delved into the roles of the DNS, the server, TCP/IP, and the browser in this process, taking the mystery out of the Internet. And that, my friends, is the magic of the Internet. Demystified. Until our next digital adventure, stay curious.